Now we're recording. Sorry about that, y'all. Hopefully this takes. Awesome. Flexibility. Let's roll. All right. So that's kind of where we're at. Thank you, Harley, for that. And then the last one is based on a confidence interval. Do we have convincing evidence for a claim? So remember this, that if we have, let's say we're talking about confidence interval, and we're talking about the AP test, and let's say that in the AP test, we find that 95%, we're 95% confident that the true average, let me see, hold up. Is this, am I sharing my screen? Can y'all see my screen or no?
No.
Okay.
No.
Cool. Let's see here.
Yes.
Awesome. Thank y'all. So like we would say, let's say we are 95% confident that the true average or the true mean AP stats test score was between 2.1, oh my word, to 3.2, okay? Let's say that that's there. Well, what does that actually mean? Well, let's say that in the context of this, we want to know if, do we have reason to believe that the true mean, let's say someone says, well, I think that the true mean is going to be 3.4. Or let's say that that's what the College Board said that it would be, or whatever the case is. And we got a sample that showed that we're 95% confident that the true mean was 2.1 to 3.2. Based on that, what does that show about whether we have convincing evidence or not? What do y'all think?
Wait, are you wanting us to answer if 3.4 like is showing significance or not?
Yeah, well, the question is like, if this is the claim of College Board that at the end of the day, there will be an average of about a 3.4 on this AP stats test. We took a sample and we found that it was 2.1 to 3.2. Do we have reason to believe that they're telling a lie?
Yes.
Yes.
Yes. Why is that?
Outside the interval.
And the interval considers 95%.
Because within our 95% interval, it does not fall.
Good job.
It's just
that's
number.
Right. So since it's outside, we would say that we do have convincing evidence since 3.4 fell outside of the interval of 2.1 to 3.2. Okay. Good stuff. Significance test. How do I write a hypothesis, right? So we know the null. If it's ever a difference, P1 minus P2 or mu1 minus mu2, that will always equal 0. Okay. And notice it is the parameter. All right. And if I was actually doing the state part, I would go ahead and define what that parameter was, very similar to what I did earlier. Okay. The name of the procedure we kind of already hit on. If it was a single one, like P1 or P is equal to or mu is equal to, like let's say that KD said, hey, his average score when he plays 18 holes is an 81. Okay.
Ouch.
So let's say that it's an 81. In that instance, if we think that it is greater, the null would be mu is equal to 81. And then the alternative would be that we think it's greater than 81. Okay? Or whatever it may be. All right? Does that make sense? The real AP Stat Award winner, are you good on that?
Yeah.
Yes.
Yeah, I'm good.
Very good. All right, the next one, use a test statistic to calculate a p-value. Well, like a test statistic would be more like what if I was talking about like the z-score or t-score, right? So how do I use table A or how do I use table B? Okay. You could also go ahead and use TCDF, but make sure if I use TCDF that when you do your lower to upper, that the value is transformed into a t-score, because otherwise your calculator won't do it. So like what I mean by that is if we're talking about this and let's say KD says that he has an 8, like he's 81 average, we think it's greater. So we take samples and we find that his average over quarantine was about an 84. Well, the question is what is that as a p-value? So the question on that is, okay, how do I find that? Well, I could do TCDF, but I can't put in the lower as 84. I actually have to transform this into a t-score. And once I do, I can put in my calculator as TCDF, whatever that t-score is, comma 99999, comma mean, comma standard deviation. And the mean and standard deviation would be 0 and 1. I think there's actually a degrees of freedom there, which would be the sample size -1, just as a heads up, okay? All right, I went through a lot of things on that piece. Any questions on that? Cool. Interpreting a p-value. Okay, so p-value is assuming, so like right over here, assuming the null is true, we are blank % confident, and the blank % would be my p-value. So like if we get a p-value of 3.03, we'd say we're 3% confident. Assuming the null is true, we are blank confident that this occurred purely by chance, that the sample occurred purely by chance. So we're blank % confident that the sample occurred purely by chance. Cool, cool. Questions on that one? Are we good with conclusions, y'all?
I think so.
Yeah.
Good, good. Okay, excellent. All right, so that is that. Let me stop my screen share first. I apologize. I'm sorry I got upset there. I came upstairs. I was pretty heated. Thank you,
It's all good.
Stephen and the Real AP Stat Award winner for helping me. So thank you all.
No problem.
And thank you also for kicking me out and for muting me. So thank you for doing all those things.
Coach, I'm gonna be honest. I was trying to kick someone else out, and then like your box appeared there, so it automatically did that one.
I'll be honest. When you did that, I was like, "Dadgummit, Katie!" Like I was a little bit, mainly because of my Surface. So
Wow, Kenny.
Dude, I wasn't even trying to kick him out.
Kenny, this is why you didn't win the award.
This is
Yeah,
true.
for
This is
real.
true.
that's right. Okay, so let's pause right now. Do you guys have any questions? I'm willing to go a little bit longer than the intended time because of our craziness. So we'll keep rolling. Unless y'all need to go, which in that case, feel free to go. Do y'all have any questions in regards to any of this stuff? Any of this stuff that we talked about, or specifically some questions that you have there?
So, Coach, just like out of your personal opinion, would you like recommend that we like write it out and submit it on our phone, or do you think it would be at all possible to like do it on our computer? I'm just kind of not unsure about that.
Here's the deal, Harley. This is a great question. I will tell you, based upon my experiences with my Surface, I don't trust my Surface. Like I don't mean that. I'm not trying to diss it or anything. If I had a choice between what I trust more, I'm going with my phone. Now, it may be a little bit more difficult to be able to scroll through. I just don't think that like trying to write on my Surface and like, I just think that I'm going to have more headaches than I just think I'll have more headaches. So I think that I would, maybe use my Surface for maybe notes or whatever, but then I'm going to have if I had my opinion, my thoughts, I would have my phone there, and then I would go ahead and I would write down on a separate sheet of paper, and then submit pictures on that. Does that make sense?
Yeah, that makes sense, Coach.
Cool.
Yeah, most people in Calc did it on their phone. I think a few people did it on their Surface, and they were able to get that. The main thing is that takes longer to submit, because if you're taking the picture on your phone, then you have to transfer it, and you have to make sure the file is the right kind of file when you transfer it. But then the phone, I think, works better, but that just takes longer to scroll. So it depends what you value more.
Right on. No, I think that's good.
Sounds like it's really a lose-lose situation.
Yes, it is a lose-lose.
It's not easy. I mean, I know that there's been a lot of people who have had issues with it. I mean, not when I say a lot, it's not like everybody has, but like if you do get there and there's a struggle there, you just do the very best you can, and then go from there. And then communicate with me if you do have issues. Yeah, that's what I would say to that. That's the best thing I can really piece of advice I would give. Any questions? Go ahead.
I had a question. So like with just like getting to like the website, like how is that going to work with like the online exam?
Like how to get there?
Yeah.
You'll receive tomorrow, because it's 2 days before the exam, you'll receive an email from College Board that'll have your AP ID and a link that you click to get to the website. So when you just click that link, it takes you there, and then you just put in your AP ID, which is on my AP, and it's on the email that they'll send you.
All right, gotcha. Thank you,
And then
Steve.
make sure when you're doing it on paper, make sure you write your AP ID and your initials at the top of the page. And if you go into multiple pages for one FRQ, label the page numbers.
Epic. Okay. Thank you, Steven.
Good stuff.
Where will these recordings be posted, Coach?
It's a good question. I'm gonna put. I'll probably end up sending. I'll put it on YouTube, and then I'll send you all the link. It's probably what I'll do.
All right, cool.
That's what I've been doing. I've got a lot of followers on YouTube, more than KD has on any TikTok video that he's ever done. So
Yeah,
for me,
right.
it actually
Yeah,
is
but
better.
all of yours are from Sweden, though, so it doesn't really count.
Now, hold on, Sweden.
Coach, can we make
Yeah,
some
Swedish
TikToks
people aren't
with you?
real people.
I would love to make a TikTok with you.
Coach makes
You know?
helpful
Yes.
What is
basketball
it? It's like,
dribbling videos.
Dun, 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 something like that.
Coach, never do that again. Oh my god.
That's like the worst trend on all of TikTok. Well, it's not the
Yeah.
worst, but it's a bad trend.
Oh man, yes.
If that tune had a physical form, I would destroy it.
Kenny, that's like not Christ-like. We wouldn't
Coach,
destroy
we
something.
should really have a
Not the
meetup at your
podcast.
house where we all make TikTok.
You know what? I'm good on
I
that.
can teach you how to make good ones.
Okay, Kenny.
Whoever gets the most likes on TikToks gets a free 5 on the AP exam.
That's right.
Coach Jay will take your exam for you.
Yeah. It'd be
Sure.
very easy to do that, honestly.
You know what? It really would be. I was actually thinking about that the other day. What would stop College Board from finding out that, like, y'all all came over to my house on Friday at 2:00, and you all just silently sat there as, one or myself or whoever just wrote the answers, and then y'all just copied them in your own words. Like,
Well,
It's okay,
Well,
Coach.
We all have identical answers.
we get different questions,
No.
Coach.
Hey, you just have to write it a little differently. Different order.
We get different questions.
I know, like, some of the history ones and stuff, like, some of my friends, they were talking about how they were able to, like, just talk through them. Not, like, they were just talking through them together.
as it was live.
Yeah.
Pretty sure that's cheating.
But they weren't, like, sharing answers. They were just, like,
That
with their cheat sheets talking through it.
that's not
Coach,
good.
it's
Yeah, but
okay.
what's College Board going to do?
No.
Coach,
like,
all that matters is the monopolization of private education.
wow.
I love nonprofits where the CEO makes millions every year. That's my favorite nonprofit.
Wow.
Bruh.
Hey, are we all salty today? I feel like we just need to have a session. I think we're all salty. You know?
A therapy session, therapy with Coach Jay.
No,
right.
I just want my free donuts. Is really what I want.
Okay, that's fair. That's fair.
Yeah, when I get the free donuts, I'll be better.
Yeah. I need to pull up to
I'm
Krispy
actually-
Kreme.
Wow.
All right, let me do this as we're having our therapy session here. I think we were talking about last week, just kind of going through some of this stuff in regards to, the specific questions linking to. I used the Stats Medic just as a baseline, but then we just went through, hey, these are things that we want to remember and maybe even include on our cheat sheet that's here. Are y'all creating a cheat sheet? Is that your desire, is to create a cheat sheet to kind of take to the AP exam? Is that your thoughts there?
That's
I'm
my
going-
desire.
Yes.
I'm going to.
Gotcha. Are y'all in the process of doing that now?
No.
I'm going to start mine tomorrow.
Okay.
Same.
I'm gonna
Um,
base it off the AP course at a glance thing that's on the website. That's what I did for calc. That helped.
Gotcha. Okay. Okay. So I know that I was starting one on the last session that we had. If you were here, was that helpful? Did y'all feel like we were rolling through that pretty good? What were your thoughts there? Last week, I think. Thought that was okay? Okay, cool. Are y'all good? I mean, if y'all need to, go and check out or do whatever, feel free to do that. That's completely up to you. If you need to go or whatever, that's fine. For the sake of the fact that, we didn't get a whole lot done because of my technical difficulties, I'm going to continue this, if nothing else, than to record it and post it. And then from there we can, you could use it however you want to. Okay. But you feel free to stay here if you want to do that as well. So as we look at this, I think last time we talked about this idea of observational versus experimental, I think is where we left off. And with that, we talked about this idea of, with observational, it's like a random sample. I'm chilling, I'm watching. Whereas an experimental, I'm actually imposing a treatment, right? I'm saying that, okay, this is the treatment that's being used, and therefore I'm randomly assigning one group of people to one treatment and then half of it to another, okay? And so within that, what I'm really looking for now is to identify, some specific terms that are there. For instance, we talked about this idea of the explanatory versus the response variable, where the explanatory would be our X and the response variable would be my Y, right? And then within that, understanding that one thing influences another. So within that, when we draw an outline of an experiment and explain it, we remember that there's specific things that we need to include within it there, okay? So that's something that we kind of left off on. As far as this is actually extremely important, and I'm sorry about my kids here. Let me try to go somewhere else on this. Here we go. We'll go upstairs here. So when we talk about defining specific equations, we're talking about the two types of equations that could come up, which in this case could be adding and or multiplying, okay? So let's say for some reason, like we were looking at an OR statement. An OR statement occurs when we're adding two different values. So an OR would be like this or that. And we remember that when we talk about defining mutually exclusive, this would be, oh, this is so good. When we have no mutually exclusive versus, yes, we do have mutually exclusive things going on right now, okay? All right, so if we say that they are not mutually exclusive, then we would have to add P of A plus P of B and subtract where they intersect. You say, Coach, why do I do that? Well, we do that because of the fact that there's an overlap that is here. So we're subtracting the overlap that's occurring here, okay? All right, so that's kind of what's occurring on this. I just want to make sure. Is there anyone? All right, Macy and Sam, are y'all still just chilling with me? I want to make sure if you're here that I'm addressing y'all as well. Are y'all good?
Yes.
Okay, cool. So like
Yes,
right
I'm here listening.
Perfect. So like, do y'all understand like mutually exclusive, what that means?
Yes.
Awesome. So I would
Yeah.
say, I would highly recommend on your cheat sheet, whether you're watching this recorded or whether it's Macy and Sam right now, I would highly recommend getting these 6 equations down. Okay. So, and let me do this because I know, do this here. I'm going to delete what's behind it just so you can see it. So this would be, again, we're talking about mutually exclusive. So if they are not mutually exclusive, you'll use the top equation. That would be a no here. This would be a yes if they are mutually exclusive. And then this is like, by definition, when the probability of A and B, where they do intersect, is 0, this is by definition what mutually exclusive actually means, where there is no intersect that's there, okay? On the right side, this is where we talk about not just adding now, but we're actually talking about multiplication. And this is talking about independence. Okay, so this independence section is this right section. Okay. And a lot of times when we talk about, this idea of multiplying, the word is and. Okay, the word is and. So this and that. Okay. So in the context of these problems, if I say what is the probability of A and B, well, by default, we assume that it's the probability of A times the probability of B given that A occurred. But if A does not impact what B is, then we could go ahead and say that it's only the probability of A times the probability of B. Okay? And you say, well, that's kind of confusing, Coach. Well, really, all it's saying is that this probability of B stands alone. And whatever happened with A does not impact what happens with B. So think about an independent event. What is the probability that Coach will make the first and second free throw if he shot? Well, if let's say I'm a 75% free throw shooter, the probability of A is 0.75, or the probability of B is also 0.75, because probability of A and probability of B are not dependent events, but rather independent events. Okay. All right. So hopefully that makes sense on how I approach it. So the top one would be no when it's not independent. And the second one would be yes when it is independent. And then the last one is just by definition, what is independence there? Okay. All right. So this next one is just, hey, how do you figure out this chart here? Like when we talk about a burger versus a sandwich, and then in comparison, in terms of fries and chips, like how that relates together. Well, if you have 2 different things that you're talking about, meaning that there's the probability of getting a burger and a sandwich, and then based upon what happens here, will change what you get, whether you get fries or chips. These are dependent events. So the best thing that I would say is to create this chart to figure out what is the probability of getting fries given that you had a burger, or what's the probability of getting chips given that there's a burger, or so on and so forth. And so you're trying to figure these out. When you do it, all 4 of these should add up to be equal to 1. So if you said if they order a burger 70% of the time they will get fries, well, that 70% would go right here. And the probability that
So like with this AP exam,
yes,
you know how we're basically just writing all of our work out on paper and then
yes.
just taking pictures of it?
Mhm.
What if there's something like this that like isn't necessarily the problem that we use to like just, like think basically on paper? are they gonna like look at that and grade it or what? Or do we need to like scrap it or whatever?
No, yeah. Include as much information down as possible. You know what I mean? And when I say
Okay.
that, Sam,
Even if it's not even right?
yeah, I would say like this right here. If you're talking about, well, because here's the deal: if you're writing down information, then I'm guessing that you're assuming that you're headed towards that right answer. You know what I mean? So, like, if you, for instance,
Yeah.
on this, if they say, what is the probability that someone that goes to the store will get fries? Well, you got to find this one plus this one to figure that out, right? Well, if I did
Mhm.
that, 0.6 times 0.7 is 0.42. And the sandwich would be 0.4. And I'm looking right here, 45% of the time. I'm just pulling these probabilities out of here. So 0.4 times 0.5 would be 0.18. So it'd be 0.42 plus 0.18. That would be equal to 0.60. Now, that means 60% of the time, people get fries. Okay? So
Yeah.
you say, well, why does that help me? Well, what you could do is this chart is definitely something that, you could include. And then once you do that, then you just kind of come down here and just say, well, let me just show just a little bit of work. Well, what is the probability of getting a burger? Sorry, let me backtrack. The probability of getting fries given that a burger happened, right? Plus, what is the probability of getting fries given that a sandwich was there? And then you could just label what does F and B stand for, and then S stand for. F is fries, B is burger, S is sandwich. And then you could just plug these in. So probability of fries given a burger would be 0.42 plus 0.18, and that equals 0.60. And that way you've got a lot of work shown. You put down the formula, and then you plug things in to get that result. Does that make sense?
Mhm.
So yeah, it's a really good question. Macy, do you have any questions on that?
No, I don't.
Okay, cool. All right, let's keep going. Okay, so here's the thing. I don't think that this is going to be like a huge thing on here, but it is something that I want to mention. It's this idea of bins versus bits. Okay. So bins, if you remember, bins has to do with a binary situation. So I make or miss, I get a hit, or I don't get a hit. It relates to something that's independent. You have a set number of successes, and you have the same probability for each shot. So if you think of it, Macy, like this, like you go up to hit, you have a 40% chance of getting a hit. Is this a binomial distribution? It obviously is. You either get a hit or you don't. Each hit is each at bat is independent. You have a set number of at bats. So let's say, what is the probability of getting, out of your 40 at bats that you get so many hits? And then S has the same probability, which would be 40%. And so that describes what we would say as a binomial distribution. Okay. Now, as far as down below, if I say, you get 50 at bats, we know that it's independent. It's a binary situation. Out of 50 at bats, what is the probability that you will get 40 or more hits within this situation? Well, what you could do is do this thing called binomial CDF, okay? If it's 40 or more, so kind of like normal CDF, except this isn't a normal distribution. We're just talking in terms of a binomial. And so if I did this, a lot of you have the lower to upper. So the lower would be 40. The upper would be 50. The probability is 0.40. And the total amount would be, I'll make it sure. Actually, I think the way that they do this is a little different. Hold on just a second. Let me do this. And you a lot of times they'll give it to you on how you plug that in terms of the binomial. But you could go to distributions, which is on your calculator on this. But you're going to go ahead and say, okay, I'm taking 50 at bats. The probability is 0.40. And then at the end, I believe that is the lower to upper. You could check on your calculator on that. But the lower would be 40 and the upper would be 50. Okay. And in fact, y'all want me to show you on the calculator some like that stuff? Would that be helpful? I don't know if that'd be helpful or not there.
I mean, the calculator's pretty self-explanatory, so
Gotcha.
it usually isn't too bad.
Good. Macy, what do you think?
All right. Yeah, I think I know all the calculators.
You know all the calculator stuff? Okay. Perfect. And you know what CDF compared to PDF is, y'all?
Yeah.
Okay. All right. So if I say, what is the probability that you get exactly 40 hits out of 50? That would be a PDF, not a CDF situation. Okay. All right. Let's take a look at some of this here. Let's see. I wanted to make sure on one quick thing here, stats. Before I go any further, let me see. Checking one quick thing, just to make sure that I said it right on that binomial side. There we go. Yeah, for you, it literally, you just plug in the trials, which is 50, just like I said, probability would be 0.40, the lower would be 40, upper would be 50. And then when you plug it in, it literally gets it out for you, that probability. So that's good. That's really good. Okay.
Coach, do you like the TI Inspire or the old 83? That's what
I
you use,
actually
right?
like the
83?
TI Inspire now that I'm used to it. It just took me
Really?
that first semester. Yeah, I think it actually will show you a lot more, even though I think the learning curve's larger. I like it. I do like it better now that I'm here. Now that I'm here on this.
Because they forced you.
Because they forced me? Well, yeah, that's the policy, yeah. So, kind of, yeah. Look down here. When we talk about combining random variables, let's just pretend that you've got a mu of x and mu of y and sigma of x and sigma of y. This may be a good idea just to kind of put this down. But if I was trying to add these two together, the means are really easy because whatever you see in terms of adding, you just add those two together. So 6.4 plus 6.2, okay? And that's all you do. So that would be 12.6. You just add them together. If it's the difference, you just simply subtract them. 6.4 minus 6.2, and that would equal 0.2, okay? Pretty simple. In terms of the standard deviation, that's where it gets a little weird. Remember, one cannot simply add or subtract standard deviations. So both of these formulas is the square root of sigma x squared and sigma y squared. And it's actually the same of whether you subtract the two values or whether you add them. So might be a good idea. If you have two standard deviations, you would square them, add them together, and then take the square root at the very end, okay? And then at this point, you know, once you kind of get to the end here, you could just simply, you know, you could square them, and that would be okay. So at the very end, you would just make sure that you would square this result to get to here, okay? So that's just, again, a thought there, just a heads up on that part. If for some reason you add a specific value, so like up here at the very top, I forgot to mention this. Let's say the mean is 6.4 the standard deviation is 1.5, and the variance is 2.3. Okay? Are y'all good right now? Y'all good to go? So if I took these hours and turned them into minutes, that means that I would multiply all of these by 60. Well, with mean, you're good. Okay? Standard deviation, you're good. And to get to variance, I would just take this value and square it to get to variance. Pretty simple, right? Like pretty much you just multiply by 60. Now, if you add 20 to it, right? So like let's say I took this value, 60 times 6.4. For the mean, I can just add by 20. But with standard deviation, you actually don't add, you just keep it from what was the original value. So when I add or subtract by a specific value, the mean changes, but the standard deviation and variance do not when I add or subtract the value. In terms of the, sorry, my surface coming in. When I look at the next piece, which is the multiplication side, the multiplication affects mean, standard deviation, and variance. Okay? So just some things to remember when you're talking about adding two values, or when I add like an integer or multiply by an integer or divide, like how it does change there. Okay? So you might want to put that on your note page just so that you've got that there. Okay? All right, normal distributions. How do y'all feel on normal distribution stuff?
Like we do it too much.
Yeah, I agree. Do y'all feel like we're pretty good there?
I think so.
What do you think, Macy? She might be out, and that's fine.
She's there.
She may be getting something. The big thing is that I may get down is normal CDF. I find area. Inverse norm, I find the value. So they're kind of opposites of each other. So the one that maybe you might want to just put down is, if I have my mean, let's say it's 1,500 here, and it says how many views would be in the bottom 5%. You have your X value here. You've got your 5%, which is right in there. And the question is what is X? Well, and then this is where, you could put your inverse norm, where you've got, here's your mean and standard deviation from what was above. And you would just put, instead of your lower to upper, you would put your X value, and then your mean and standard deviation, which would be 4,000. And I said your X value, what I mean by that is the area. So this would be area, mean, standard deviation. So the area of this would be 0.05. And with area is always to the left. Okay? So that's why we put 0.05. If it was the upper side, you would put 0.95 because you want to try to find the area to the left of that value that's there. Okay? So you put 0.95 in order to find what is X. And so inverse norm allows me to find the X value, whereas normal CDF allows me to find the area. Okay?
Could you also use
Clarence.
Yes,
on that?
Say that again.
Could you also use table A for those?
You absolutely could. And in table A, if I did that, you would want to make sure you go to 0.05 and relate 0.05 to my z-score.
Okay.
Does that make sense? And then from there, you would use this up above. So let's say the z-score was negative 2.4. I'm making this up. And the X value, you don't know what that X value is, right? The mean is 1,500 and the standard deviation is 4,000. Now you have to use basic algebra, multiply by 4,000 on either side, and then add by 1,500. Okay. Good question. Trying to think of anything. remember what a statistic versus a parameter is? We talked about this earlier today, but just denote what is a statistic, what is a parameter, how do I, use that there? That's going to be important. What makes a good statistic? One that has low bias and low variability. That's very important. Low bias and low variability. This is a sampling distribution. Now, you probably have a lot of this throughout, the lesson, and the fact that you have done all the confidence intervals and significance tests, you probably have seen most of this before, but this might be a good chart just to have. But remember that a sampling distribution would be different than a sample distribution. So like if I say, what is the probability that A randomly selected ... whatever the context is, versus a sampling distribution was not A randomly selected, but maybe 50 randomly selected, and then go from there. So A versus 50, that is the difference between what we did originally when we talk about a sample, like a sample distribution, versus a sample of a sample, which is a sampling distribution. Okay, y'all, does that make sense for y'all?
Yeah.
Okay, cool. And that's why also, like, if you see mu of x bar, all that means is it's the mean of the sampling distribution for mean world. So remembering that, because that is something that a lot of people struggle with or have difficulty on. Okay. All right. Trying to think of some other thoughts here. Do y'all have all of these filled out, by the way? So these are like all of the confidence intervals, significance tests. These are all of the ones from chapters units 6 and 7. Did you get all these filled out, y'all?
I did.
Sam, did you?
I think so.
Okay. Highly recommend going back and just making sure.
Is that from last week?
This is from unit 6 and 7 from the Stats Medic. Okay. And the reason why this is important.
Oh, yeah.
When you go to here, and like at the top, it should say, if you don't have it, then, put it there. Like it says 99% confidence interval. Well, it's an interval. And then you go up on top and that we're talking about mean world because it's talked about, here. And it says for the true difference. So what we're trying to do is find a confidence interval of mu1 minus mu2. That's the parameter. So this would be a 2 sample T interval. That's the test. So I would actually put this at the top, staple all of these together, and just in case you need to go back to it. I would not recommend all of these be right there in front of you because it could overwhelm you and you don't really have the time to flip through all of them. But if you notice that, oh man, this FRQ is a 2 sample T interval and it's asking questions related to it, you could always go back to this and pull from some of the notes that you had on here. So I don't recommend putting all of this stuff in your notes, but I do recommend just kind of labeling it so you can go back easily to it there. Okay. All right. Oh yeah, this is a mini tab. This is really, really good. Okay. In the mini tab, the recommendation that I would have is if you see this, go straight to COEF. Okay. And the easiest way to make this into a least squared regression line is just to say, okay, the constant is the number by itself. And the number that's associated with the variable, usually it's second, goes with X. And then it's equal to Y hat. And if I were to put this in the context of the problem, we would put, for X, we'd put % of free and reduced lunch. So we would just say, instead of X percent free reduced lunch, and then put this number here, plus 577.9 equals, and then the hat would be the average SAT math score. So average SAT, and then I put math score there. But that would be the context of using a least squared regression line, okay? So just as a heads up, if you're trying to do that, this whole concept of what it's talking about with the advanced least squared regression line stuff was in the unit after the one that we did last. So just a heads up on that piece, okay? All right, any questions, y'all?
I don't think so. I'm actually gonna have to go,
That's
but
fine. I'm actually about ready to
I
wrap up.
appreciate the extra.
Yeah, I'm sorry about today. Sorry about the craziness. Hopefully that made up a little bit for it. Tomorrow from 1 to 4, we're going to really get after it and kind of take it little by little and hopefully create some stuff that's there. You know, like I thought about, would it be helpful if we did like a Google Doc tomorrow and like we'll just review some of this stuff and then, you know, we'll just create one common cheat sheet for everybody. Would that be helpful?
Yes.
Yeah.
Okay, maybe we'll do that tomorrow. That might be a good idea. That might be a good idea there. So, nope, that sounds good. That sounds good. So, y'all have a great day. Macy, do you have any other questions?
No, I don't.
Okay, excellent. Thanks for coming today, y'all. We'll see you.
See ya.
Thank you.
Yep.
Bye.